Hello, I'm Nick, and I'm Nick. I'm a member from the Bitlayer research team, and I'm excited to be here to share our journey and experience in building a Bitcoin native rollup. And we'll explore the challenges and alternative solutions on Bitcoin rollup over the next 25 or 30 minutes. So before we dive in, we'll give you an outline of today's talk. And in the first part, we'll talk about the significance of Bitcoin rollup and the associated challenges. And then we'll talk about our solution that's building the Bitcoin from the scratch. And then at the third part, we'll talk about the current status of our technical preview and take a deeper look at what happens during the rollup protocol, especially on-chain transactions. And finally, we'll give a roadmap for our future development and other future plans. Okay. So we know that Bitcoin has been known for its security and strength, but with the development of blockchain, it is a huge demand on expanding its capability. We know that sidechain can offer the functionality, extend the functionality to Bitcoin, but it often requires users to take their trust into the external validators. Well, Rollup can inherit the Bitcoin security that have no harness to the trustlessness. So this is the most significant difference from the sidechain. Also, we are expecting the Rollup to give it to extend the programmability and scalability to the Bitcoin so that we can offer a wider range of applications to be accommodated. So at last, and we want to talk about is the interoperability. That Rollup can take facilitate easier interoperability between the Bitcoin and many other blockchain ecosystems, so that will positioning the Bitcoin into the core of a more interconnected crypto landscape. So since the rollup can have so many benefits, uh, why not to design a practical native the Bitcoin rollup? We find there are many challenges. The first is the limitations from the Bitcoin, the UTXO models, and the Bitcoin scripting limit the capability to represent the state transition and verification functions on chain. Also, there are many challenges from Rollup itself. We need to design a trust minimized bridge. From now, most challenge on Bitcoin used MuSig. We are expecting to use OPCAT and Covenant to provide a trustless bridge. Also different from Bitcoin, Rollup would have a much different or radical strategy to update its own protocol. So we need to carefully design in our protocol to avoid that any future update will break the security and trustless from now. Also, we're expecting to have a graceful user exit window and escape hatch in many different scenarios, especially when the operator from layer 2 that is not responding or outage. So all of these challenges requires thorough consideration, and a thoughtful solution needs to be addressed and to create a really practical rollup protocol. Here is our solution to building the native Bitcoin rollup. We're taking advantage of the zkVM to provide the verifiable proofs of arbitrary computation, so that we can avoid or we can address the programmability that limits from the Bitcoin script. Also, BitVM2 has showed us that the feasibility of block proof on chain on Bitcoin. But also with the future enabled OPCAT, we can easily to run to implement a validity proof during the rollup. Also with a very for a practical rollup protocol, we need to achieve the state transition finality on Bitcoin with confidence. So here is our solution to the Bitcoin rollup protocol. Right? And here are the key takeaways. So for the following parts that we will talk about our solutions on Bitcoin rollup. And let's take the architecture first. On the top of the paragraph is the layer 2 platform, and in the center is called coordinator. It managed the whole proving process when a layer 2 block is generated, so that it can provide a valid batch proof to the operator. The operator watching and the governance consist of the whole the roles in the rollup protocol, that the operator takes care of pushing the new batch statements to Bitcoin, and also addressing the challenges from Watcher. Watcher takes care of the security from the rollup. It monitors every step that operator acts, so that when an operator try to cheat, the Watcher will start the challenge that makes sure the rollup is working properly. And governance can be seen as a consensus network composed of multiple nodes. That it has various responsibility. One of its duty is to pre-sign transactions as an implementation of covenant, just like federation in BitVM. Right, then let's take a deep look at how the coordinator managed the proving process. From the start, when a block is generated, the first stage is STF. It takes the state with the corresponding macro proof, and also the block into the zkVM to rebuild in zkVM. It generates the STF output as the claim of the proof. It not only take the record the state before and after the block, also take an additional field called data that used in the following stage. For now, we record the transaction root and state diff. Also, when all the proofs during the STF proofs in a batch is produced, we will push them into the next stage called batch aggregate. It chaining the STF outputs into a chain output that records the state from and to. Also it records the code commitments that generate the proofs called STF code commitments. It will be checked in the later stage. Also additional DA proof is provided here to make sure that this batch is already settled on DA layer. Then this batch proof will be input into the next stage called batch recursive. This stage is called recursive since it will also receive another proof that's produced from the previous iteration. Then the batch proof also take another input called code control group. This is used to make sure the adherence of all the proofs are produced by the correct program versus the genesis block. Because we don't have the statement representation like Ethereum, so we like to keep all of these states as short as less as much to push on the chain. And then we will have the final stage. It takes the recursive proof as the input, it not only normally it would use another proving system for the from the previous stage, because it needs to adapt to the on-chain verifier script. So for current, we are proving the final proof program in growth 16, and to make more convenient on-chain verifier, we will compress the code control group into a single hash called control root, so that it will be easier for the verifier script to construct the value. Then when the final proof is produced, we need write the correct verifier so that we can verify it on chain, either in a raw proof or validated proof. Well, here is our Bitcoin script, and we can see the white color text, the batch proof from 2 and the data indexer is provided by the operator from there too, since they change every time. Also, these 4 fields are the input of our script. And the other script, code control root, genesis state, and another final code commitment is hard-coded, since they represent the whole code commitments from the beginning as a consensus, social consensus, so that governance would check the code if you are correct, and the compiled program is correct. And then all this information will compressed into a claim hash in Bitcoin script and take it into our growth 16 verifier script. So since this script, since this transaction used to construct the final output, all these concerned values are hard-coded. So any user would not disagree. Any user would disagree with the code, since they do not agree with the next few days upgrade on our protocol. They will have time to exit the rollup by submitting their to exit by submitting their transfer to the Bitcoin or our L2 to slash their address. And then we'll talk about our rollup protocol. Here is the overview of our UTXO transactions on chain. The rollup protocol starts with a bootstrap and follows by the commit batch transactions. If everything okay, then the batch will finalize with a withdrawal transaction that the operator will take his collateral back. Otherwise, the commit batch will be challenged by the watcher, and the operator, after the challenge is alive, the operator will have to respond to the challenge, and any misbehavior will cause the slash transaction at end to slash his collateral as the punish. Right. So the bootstrap is the very first transaction that should be public to the network, so that everyone knows what it's like in the first place in our layer 2, right? As submitted by the operator. And second, before we submitting commit batch, we need a separate phase called preparation. That is a necessary before the OPCAT to implement a covenant by taking the responsibility from governance. The operator that provides big commitments and many other information to the governance, so that the governance will reconstruct the next rollup transactions that will and then pre-sign them. Also, these transactions in the pre-signed transaction, including the commit batch and withdrawal transactions. And these transactions will be broadcast to both operator and watcher, so that watchers will know that what's the next commit batch transaction ID is, and then he will subscribe to the transaction to make sure that the operator is working properly. Then when the batch is ready to submit, that the operator needs to fulfill the other missing field in the transaction, including many big commitments, values, and many other things to complete the transaction and sign them into a complete batch transaction and commit to the Bitcoin. Also, when the commit batch is alive, the watcher will subscribe to the Bitcoin so that he can recover the proof and many other information from the commit batch transaction, and then he will run the verifier script locally to check whether the operator is working correctly. If nobody challenge, also to be know that anyone can be the watcher since all the information are public, including the transaction ID and the script. So everyone can challenge the operator, but it has its own collateral. We'll talk later. Well, if no challenge occurs within the challenge period of the commit batch transaction, operator will produce the broadcast, will proceed to broadcast the withdrawal transaction to retrieve the collateral. And normally, this collateral will use for the future collateral will use as a collateral for the future commit batch. Also here we'll talk about the challenge case that if the operator submit the wrong information about commit batch, especially if maybe a fake proof or the wrong state with the proof, mismatched state with the proof, that watcher will definitely know that it is cannot pass the verifier script. Then he will send the challenge transaction to the network to start a challenge game. Also the challenge, the operator should respond the challenge as soon as possible. But if it fails to respond in a period, then the watcher can directly send the timeout / to win the challenge game, and also take the collateral as a punish for the operator not responsive. So if the operator successfully responds, especially for it has to reveal all the intermediate outcome of the subprogram of the verifier script and the input and output of the verifier script, and then the watcher can take all these the messages, the information from the response to find out which is the actual mismatched fit, or we can call field subprogram that we can slash. After identifying the subprogram, that watcher will slash the collateral by submitting the corresponding intermediate values, so that the on-chain script will definitely run into a failed case that will lock the collateral to take the collateral from the operator. Otherwise, if this challenge game is initiated by an evil watcher, that should never happen. For example, the operator works as expected, then he will not be able to generate the slash transaction. Then after the period of challenge, then the operator still can submit the withdrawal transaction to Bitcoin to take its collateral back. Right, that's the whole protocol of our rollup. Also, we like to have information about our bridge. Besides the BVM bridge, we also enabled a fast packout mode. This is a ongoing design that by leveraging the responsibility from governance that we add an additional output to the withdrawal of the rollup protocol, and governance will assign the special ticks as the pass packout transactions to the for the users to pack out, so that the users will get their backouts as soon as the rollup reaches finality. Also, we expect the governance will be removed after OP-cat is enabled, so that we can have the covenant to automatically for every user to take their money back. Okay, let's talk about our technical preview. We are currently in early stage development, but our code is fully functional now and featuring a complete end-to-end rollup protocol. And today's technical preview, we will talk about emulate two different cases. The first is the happy pass, just like for the commit batch 1, that the operator provides the correct proof, and the challenge pass that will finally slash the operator's collateral, since he submit the invalid rollup with the rollup proof with the tempered program. Also, let's take a look at the Bootstrap. Bootstrap has only one input and one logical output. The input comes from the operator to provide the transaction fee for the transaction. Also we have a one logical output to provide big commitment for the commit state and the batch proof used in the next commit batch. Okay, let's speed up. Here's the detail of the Bootstrap transaction, and we can see that the logical output is composed of 9 actual output to the current Bitcoin. Yeah, and then the commit batch transaction. First, it takes the output from Bootstrap. Also, it has another input from operator as is the collateral. Also, we have the 3 logical output. The first is just like the Bootstrap. It provides the commit state and the batch proof commitment. The last 2 is the connector. The connector is used to lock the collateral used in the next output. Okay, and here is the detail of the transaction. And then let's talk about the happy pass withdrawal. The happy pass withdrawal take 2 inputs that directly from the commit batch. The first is the connector and the collateral. Also the out is the operator provided address that he will take her money back. So here we can find in our technical preview, we said the unlock time of the collateral of the batch is the 200 block, which we can see in the top right corner that C8 is the 200 block. Okay, the commit batch 2 is just like commit batch 1, but it provides the invalid proof in their witness data. And then the challenge transaction is provided by is submitted by the challenger that that he needs to provide additional Bitcoin so that cover the expenses for the operator when the challenge game happens. Also, since the connector is consumed here, the operator cannot take his money back from the withdrawal transaction in the happy path. Then the response here, we need to reveal all the values during the challenge game and to know that in current Bitcoin we have split the response into many transactions that to make sure that all the information can be revealed. And now we will take it into 5 transactions. Here is the actual transactions that we submit during the response phase. Also, the challenger will finally find the mismatched subprogram from the values revealed in the response, and then he will submit the value that revealed in the last stage, and then he will get V minus B for him, and will burn B for the punish for the operator. And for now, in our implementation, we did not enable burn for now. We will make it in the future. Then that's the whole part of our protocol technical preview for the whole transaction and what happens on chain. Well, I will have another talk about our roadmap. The code of the technical preview will be open sourced in the following weeks, and as the foundation of the Bitlayer V2, we will continue to implement and contribute features to our Bitcoin rollup, including EA and a native token bridge, or false inclusion, transaction operator rotation, and most important is the verifier script size optimization to meet current Bitcoin consensus rule. Also with the OPCAT enabled, we will turn the proof from fraud proof to validity proof for our stage transition finality. And we will enhance our layer 2 platform to provide a real-time BitVM for our users. And that's all. Thank you.